So we're picking up where we left off the end of last week. Last Friday, we talked about the unit circle. Yes, we just reviewed the first quadrant. And we learned that the x and y coordinate give us important information about two of the trig functions. So if I'm looking at the values for the x coordinate, which trig function values is that giving me? If you're not sure, you can check your 1B notes. Cosine, very good. X is the value of cosine. And y is the value of sine. So x comma y or cos comma sine. Notice both of those are alphabetical order. That will help you remember. And if we know cos and sine, we can find the other four trig functions. Tangent is sine over cos. Secant is 1 over cos. Cosecant is 1 over sine. Cotangent is cos over sine. Those are fractions that are also on the equation sheet that I will give you on test day. So if you forget that, those fractions are going to be given to you. You should be able to use coordinates on the unit circle to be able to find them. Yeah, and we practiced that on Friday. Good. We're going to practice a little bit more, and then we're going to learn some new vocab. So for our first example, it says given a point P. In this case, we have a certain angle T corresponds to a point on the unit circle 1/2, comma, square root 3 over 2. It says find cosine T and sine of T. So cos and sine. And we know that ordered pairs on the unit circle are cos, comma, sine. What is the value for cosine for angle T? 1/2. 1/2. 0.5. Perfect. What is the value for sine? Square root of 3 over 2. Very good. I also can tell by looking at that point which quadrant I'm in. Which quadrant is that ordered pair sitting in? 1, 2, 3, or 4? 1, because it's positive, positive. Good. So these values are for quadrant 1. Good. Very good. Next one, certain angle T corresponds to a point in the unit circle negative root 2 over 2, comma, root 2 over 2. Find cos and sine. Ethan, what is cosine of that angle for example 2? Yeah, negative root 2 over 2. Perfect. Very good. Luna, what's the value for sine at that point? Positive square root of 2 over 2. Very good. Lupe, based on that point, which of the 4 quadrants are we in? 1, 2, 3. 1. So remember that 1 is to the right and up. So x would be, I go to the right, is x positive or negative? Right's positive, up is positive. So if I were in 1, it would be positive, positive. That was example 1. For 2, I've got negative, positive. Can somebody help Lupe out? Where does that put me? 2. 2. So remember for your unit circle and the quadrants in general, if this is my coordinate system, this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. And I can see this is positive, positive, negative, positive, negative, negative, positive, negative. And that's important because when we start talking about inverses instead of reciprocals, we're going to have to limit our trig functions to only 2 of the 4 quadrants. So it's important to know the names of the quadrants so we know where our trig functions exist and where they don't. So this guy is in which quadrant? 2. Very good. Happy face. Good. Okay. Angles on the axis behave the same way. Those points are still cosine comma sine. So if I am at 90 degrees, you go back to your bell ringer. What is the x coordinate at 90 degrees? 0. Cosine is 0 at 90 degrees. What about sine? 1. Good. That should make sense based on what you remember from Math 3. As you've seen those graphs before, yeah? So I know that sine starts at 0, goes up, and then comes down. I'm hoping that looks familiar. I know that cosine starts at a peak, comes down, and then goes back up. So we're right here. We're at a max for sine and a min for cosine, or a 0 for cosine. Good. Next one says find sine and cosine for pi. Sine and cosine for pi. And I'm pretty sure 0 degrees is the positive x, 90 degrees is the positive y, 180 or pi would be the negative x. I'm sitting over here. Raise your hand if you can give me the coordinates for x and y at that point. Cecil. Very good. Cosine is -1, sine is 0. For that point, sine is here, cos is here. Yeah. Good. Good. Hopefully, not too bad. So you saw on Friday, just picking off the x and y coordinates. Yeah, if I wanted tangent, I'd take sine divided by cos, y divided by x, right? I wanted cosecant, I'd take 1 divided by sine, which is 1 divided by y. That's great if I'm at an angle where I know the coordinates on the unit circle. And we saw from our warm-up today, if I go back up, that's only 3 angles in each quadrant, and then the 4 axes. So that's 12 plus 4, that's 16 points. That's not a lot, because there's an infinite number of points on that whole circle. So the question is, if I have one of the trig functions, sine, can I find the other function, cosine, that goes with it? Or vice versa, for angles that are not pre-built on our unit circle? And the answer is yes, we can, thanks to that crazy guy Pythagoras. Little Mr. Greek cult guy came up with another identity that is based on his original Pythagorean theorem. We know that x squared plus y squared equals the hypotenuse squared. A squared plus b squared equals c squared, yeah? We know that the hypotenuse in our right triangle for a unit circle is 1, because the radius is 1. So x squared plus y squared should be 1 squared. But x is which trig function? Cosine. So x squared is cosine squared. Plus y squared. What trig function is y on the unit circle? A y coordinate is which trig function? Sine. So y squared is sine squared. That's leg squared plus leg squared, x squared plus y squared, sine squared plus cosine squared, equals hypotenuse squared. Hypotenuse is 1, 1 squared is 1. Cos squared plus sine squared is 1. Yes. Yes, that is a t and then a plus sign. If it helps, we can do this so you know the t is the argument in the trig function. Yeah. It is, because I'm a messy writer. I'm sorry. It turns out writing on glass with a pen is hard. So I can use the Pythagorean theorem written specifically for the unit circle, which becomes the Pythagorean identity, to find other trig functions given either sine or cosine. So if I know cos, I can find sine. If I know sine, I can find cos. And once I have both of those, I can find the other 4. So we're going to do some examples to get some practice using that identity. Yeah? Deep breath. All right. So first one says, we know that sine of angle T is 3 divided by 7. Don't know what my angle is. I know it's not one of those prefabs 30, 45, or 60 because that's not a fraction over 2. But I know that sine is 3 over 7. I want to find cosine. So we're going to use the Pythagorean identity. Pythagorean identity tells me that cosine squared of t plus sine squared of t equals 1. And I have one of those 2 trig functions. I have sine. So I'm going to plug sine into that formula. And you'll notice in the formula, it's being squared. So I'm not going to plug in 3 over 7. What am I going to plug in? Yeah, 3 squared over 7 squared, which is 9 over 49. I think I can do math in my head. And I want to solve for cosine. And I know from math 1 and math 2, if I want to solve for something, it means I need to get it by itself on one side, move all of the numbers and other operations to the other side. So the question is, if I want to solve for cosine squared, I want to isolate cosine, what should I do first? Raise your hand if you see it. Seesaw. Very good. We're going to subtract that 9 over 49. I'm going to subtract this constant from both sides. So I'm going to end up with cosine squared t equals 1 minus 9 over 49. And off to the side, I'm going to do a little fraction math. In order to subtract fractions, I need them to have the same denominator. So I want something over 49 minus 9 over 49. That first fraction should be equivalent to 1. What should my numerator be? 49. Very good. And what is 49 minus 9? 40. Yeah. So cosine squared of t is 40 over 49. Perfect. And I have a question for you. I want to solve for cosine, not cosine squared. How do I undo a square? Square root. Very good. I'm going to take a square root of both sides. So square root of cosine squared, square root of 40 over 49. And I get cosine of t. That's the thing I want. Happy face. And then square root of 40 over 49. And I have a conundrum. When I take a square root, I get 2 answers, a positive answer and a negative answer. I pick up a plus or minus when I take square roots. And that's why they told me that my angle is in the second quadrant. That tells me something important about the sign on cosine. I go back up to my little picture. Remember that cosine is the x-coordinate. In quadrant 2, is the x-coordinate positive or negative? Negative. When I take that square root, I want the negative answer because I know I am in quadrant 2, and x, which is my cosine, is negative. The Pythagorean identity will give me the appropriate absolute value It'll give me the fraction that I want. I have to use the picture to figure out the sign on my answer, positive or negative. So there's two moving pieces. The fraction itself comes from the Pythagorean identity. The sign comes from knowing which quadrant I'm in. Good. I'm going to start with the denominator. What is the square root of 49? 7. That makes us happy. It should have the same denominator because remember that denominator for sine and cos is our hypotenuse. They're coming from the same triangle. They should have the same hypotenuse. Sine and cos should have the same denominator. Question is, what happens on top? Square root of 40. Square root of 40. I know that 40 is 4 times 10. What is the square root of 4? 2. 2. So square root of 40 is 2 square root 10. And I should record it as 2 square root. Yeah. Good. Good. Deep breath. It's going to be okay. Happy face. Yay. All right. I want you guys to try the same idea for example 2, and then I'm going to call on some people to walk me through it. I'm going to give you about 2 minutes to get started on example 2. I don't know if you've noticed, but my back table back there is absolutely stuffed with stuff that needs to go in here. But all of this is disorganized. Yeah. It's not bad. I just want it sorted by like art supplies. All of the supplies, art names, so that I'm getting in and out, I know where to find stuff. So I'll prep the labels today for the shelves, and then you can just organize it by label. Thank you. That's Hello Kitty, isn't it? Yeah. I love Hello Kitty. That makes me happy. What's up, Sylvia? Sine squared plus cosine is 1. That's okay. They will be really big. At some point, we know we're going to take a square root, and that's going to become 25 again. And that will probably, once it's been subtracted, it'll get a smaller number that'll be easier to square root. Yeah. So far, so good. What's up, Cecil?
1 over 5.
Shouldn't be 1 over 5.
No?
Notice this is squared. So it's not 1 minus 24 over 25. It's 1 minus 24 over 25 squared. And you're going to get big numbers so that when you undo that square later, the denominator will be 25 again. Because remember, sine and cos should have the same denominator. I'll give you about 30 more seconds. We are not in second period. We are in fourth period. Yes, sister. So 625 minus came out to 49, and square root of 49 is 7. That's perfect. Yeah. Yeah. Okay, let's see. Who is our first person who's getting voluntold today? Alex. All right, starting with example 2. Suggestions on how we would start, Alex. Cosine of 24 over 25? Let's start here. I agree that at some point 24 over 25 is going to come into play. That's our Pythagorean identity. And cosine is 24 over 25, so this whole thing's going to get replaced with what? What is that telling me to do to that fraction? Square it, yeah. Notice that this doesn't have a squared. So cosine by itself is 24 over 25. I want cosine squared. So yeah, we're going to take that bad boy and square it. Yes, that's ugly. Yes, those are big numbers. That is okay. We're in college math. We can deal with big numbers. That's what calculators are for. Good. So 24 over 25 squared plus sine squared equals 1. And we're going to square that. And I don't know off the top of my head. I know the bottom is 625. What is the numerator? 576. Thank you. So plus sine squared equals 1. And we're going to proceed the same way we did last time, which is to do what? So let's see. Who can I pick on next? Oh, sad face. Vicky's not here. And Jean's not here. Find all the absent people in one row. Luna. Go back to our page here. What do I do next, Luna? Good. From both sides. Perfect. So sine squared t equals 1 minus 576 over 625. Very good. Perfect. And I know when I do that subtraction, the 1 is going to become 625 over 625. So we get sine squared t equals, and 625 minus 576 is 49. 625. I get some nodding. Perfect. And then we go back. We pick on someone else. Anila. What do we do next? Yes. Very good. Square root. Square root. Very good. So sine of t equals, and I know that square root is going to give me the correct fraction. I need to worry about the sign. So I'm going to go back to that word problem. T is in the fourth quadrant. Fourth quadrant. Sine is the y coordinate. in that unit circle. In quadrant 4, is the y-coordinate positive or negative? Negative, because we're down here below the x-axis. Yeah, good. So I know sine should be negative. Whoops. And the square root of 49 is 7. Square root of 625 I know is 25, because I know sine and cos should have the same denominator, because they're both over hypotenuse. Good. Very good. Reminders that once you have those fractions, you can start finding all the others. I know cosecant would be the reciprocal of sine, negative 25 over 7. Yeah, I know that tangent would be sine over cos, so it would be 7 over 24, as the bottoms would cancel. Good. Very good. Okay, questions on those examples? No. All right, we're going to spend more time with this identity, because this is one of the most powerful identities for doing almost anything with trig functions. I can rewrite trig functions as other trig functions using this identity. I can find missing trig functions giving only one. I can use this identity to massage expressions into other expressions when doing proofs. We're going to see this over and over and over again. You're making fun of me, aren't you? It's okay. I know I'm silly. You'll notice here, whoops, I was nice and I gave you all of the information for the first quadrant of the unit circle. Again, nice and summarized. The version in Google Classroom and Canvas is color-coded for your convenience. And we saw that information on Friday. Yeah, good. Okay. What we're going to do, and we're going to start now, we'll finish tomorrow, is we're going to look at where those ordered pairs come from. Because when I saw you on Friday, we just slapped some numbers on the picture based on what you guys remembered from Math 3. Now we're going to look at where those numbers came from. Where did that square root of 2 over 2 come from? Where did that square root of 3 over 2 come from? Yeah? Yes. Did you make E-Hall? Yeah. All right, we're going to start with the 45, and I'm going to draw some pictures because I think that math is easier when I have a visual of what the heck is going on. So I'm going to start by drawing a picture. Yeah. All right, so I know that 45 degrees is that halfway point in the first quadrant. So that's that 45 degree. And I'm going to draw my lines in pink to make them stand out. So that's the radius at 45 degrees. And what I'm going to do is I'm going to draw what am I going to draw? A right triangle by dropping a vertical line down this way. And let me zoom in so that's nice and pretty. And I'm going to label some things over here. What is the hypotenuse of that right triangle that we just drew? 1, because this is a unit circle. Perfect. I know that is 1. I know this angle down here is 45 degrees. If this is a right triangle, I have a 90-degree angle. I have a 45-degree angle. What is that third angle at the top that doesn't have a label? 45. This is a 45, 45, 90. If those two angles are the same, what do I know about their corresponding sides? They're the same, because angle measure has to do with side length. Bigger angles produce bigger opposite sides. If those angles are the same, their opposite sides should be the same for this triangle. So normally I would label these sides x and y, but because I know they're identical, I'm going to label them x and x. And I'm going to figure out what x is by using the Pythagorean theorem. A squared plus b squared is c squared. Leg squared plus leg squared is hypotenuse squared. So off to the side, a squared plus b squared equals c squared. So x squared plus x squared equals 1 squared. On the right, what is 1 squared? 1. We like that. That makes us happy. On the left, x squared plus x squared is what? If we were multiplying, we would end up with x to the 4th, but we are adding. Adding doesn't change exponents, it changes coefficients. 2. Yeah, this is 2x squared equals 1. Perfect. I want to find out what x is, because once I know x, I know both coordinates of the point on the circle. What do I do to get x by itself? I'm going to divide by 2 first, because we're doing reverse PEMDAS. Reverse PEMDAS. So this is x squared equals 1/2. And we square root to undo the square. Perfect. So we get x equals, the square root of 1 is 1. Square root of 2 is square root of 2. You'll notice that is not what we see as the coordinates for this point in the unit circle. Why? Very good. There is a square root in the denominator of that fraction, and that makes mathematicians cry. I need to rationalize the denominator. Turn that radical into an integer. How do I do that? Yes, multiply by itself. Good. Top and bottom by root 2. I'm allowed to do that because that's effectively multiplying by 1, which doesn't change anything. On the top, what is 1 times the square root of 2? The square root of 2. In the bottom, what is the square root of 2 times itself? 2, because that's the square root of 2 squared. Good. You will notice that that is exactly what we expect for our x coordinate at 45 degrees. That's what we slapped in there based on memory for Math 3. Because at 45 degrees, the x piece and the y piece are the same, what is my y coordinate? Square root of 2 over 2. Ooh, except I'm not erasing, I'm writing. Those numbers that we were picking off from memory are actually coming from the Pythagorean theorem you learned back in Math 2. We know the hypotenuse is 1. We know the side lengths are the same. Good. Perfect. We're going to set up the next one. We won't finish it because we get out at 14 today because we got a short schedule. Yeah. Before we do the next one, questions on that first one? Nah. You'll notice a lot of what we're doing is Pythagorean theorem. If you're comfortable with Pythagoras, trig is going to be good for you. Yay. Next one, we're going to do 30 degrees. Similar idea. So I knew 30 degrees is kind of low. Yeah, it's less than 45, so we're down here somewhere. And I'm going to do something a little bit different in that I'm going to start by building a right triangle. Drop this side down. And I'm going to take that right triangle and I am going to reflect it about the x-axis. So I'm going to take this point and find its buddy down here and redraw that right triangle for that new point. And we have some very interesting symmetry here. If this tiny little angle here is 30, and I take that 30 and I reflect it, what's the total angle here? 60. 30 plus 30 is 60. So this angle down here is 60 degrees. The top triangle and the bottom triangle are reflections of each other, meaning they should have corresponding sides and angles that are the same, meaning this angle and this angle must be the same because they're in corresponding spots of the triangles. I know angles in a triangle have to add to 180. I know 60 degrees is already taken up. 180 minus 60 is 120. I now have to take that 120 and cut it in half to equal angles. What's half of 120? 60. Yeah. This is 60. This is 60. This is a equilateral triangle. All of the angles are equal, which means all of the sides are equal. We know the side lengths. What's the radius of this circle? 1. This is 1. This is 1. This whole thing is 1. I don't want that whole thing. I want just this piece, which would be what? 1/2, because it's just a reflection, right? The axis cuts it in half. Yeah. Which is why my y-coordinate there is 1/2. The question then is, how do I find the x-coordinate? Louder. Pythagorean theorem. A squared plus b squared is c squared. Like I told you, you're going to get so sick of that, you will be able to do it in your sleep. So my legs are x and 1/2. I know the y equals 1 squared. Bless you. We're going to simplify. Yeah. X squared plus, and I know 1/2 times 1/2 is 1/4. And 1 squared is 1. I want to solve that for x. We're going to subtract 1/4 from both sides. 1 minus 1/4. What is 1 minus 1/4? 3/4. Perfect. How do I undo that square? Square root. So x is the square root of 3/4. What is the square root of the bottom? 2. Yeah. Square root of 3/2. The derivation at 60 degrees is the same idea, except the whole 60-degree triangle is now in quadrant 1. But you will end up with a similar idea, but now x and y are switched. Reminders. What's due today? Homework 1. Very good. Lunch is the same length. 5th period starts at, no, advisory starts at 1. Sorry. Advised, you need to be in your advisory class by 1 p.m. Yes, I can. Let me stop my recording first.